Hello, chemistry students. This is Gray coming to you with some molarity practice. So you just watched a video on molarity, but you really didn't get a chance to practice. We only had one practice problem. Not very helpful. We need to have some more practice on molarity. Just a reminder that molarity is equal to moles over liters. That's how we can solve for molarity. And that you can see up here, right? We have molarity, moles over liters, if we want to use our triangle. So first we want to identify our moles and liters in our problem. So 0.5 moles, I'm going to box that number in unit, of sodium chloride is dissolved to make 0.05 liters of solution. So if we have molarity is equal to our moles, so we want to have our moles on top, over liters, so we put our liters on the bottom. And now we solve by dividing those two numbers. So let's get out a Google calculator. What was it? It was 0.5 divided by 0.05. And that is 10. So we are going to have an answer of 10 molarity. So capital M is our unit, and the number is 10. Looking at our next problem, again, we have our equation up here, moles of solute per liters of solution. So 6.67 moles of lithium sulfate are dissolved to make 2.500 liters of solution. So we want us to do the same thing. We want to have molarity is equal to, that R looks weird, is equal to our numbers. We're going to put our moles on top. And we're going to put our liters on the bottom. Again, we divide those two numbers. Is 2.668. I'm just going to put 2.6 or 2.7. I'm going to round, kind of lazy like that. You know me. So 2.7 molarity is our answer. Again, we've taken our moles, we've divided by liter. This tells me my concentration, that I have 2.7 moles of solute in 1 liter of solution. So that is what we are determining. We're determining how much is in 1 liter, and we have 2.7 moles in 1 liter. That's what we have. Going on to the next problem. Again, we're still looking at molarity. We have 0.151 moles of PbC2H3024 are dissolved to make 3.5 liters of solution. I want you to pause the video now and practice finding the molarity of this solution. So welcome back. You should have put moles on top and liters on the bottom to equal our answer. So we have 1.15 is 0.043. Again, capital M is our units, and that tells me I have 0.43 moles per liter of solution. Finally, our last problem here, what is the molarity of a solution containing 3.083 moles of FeCl3 and enough water to make 500 milliliters of solution. This time, we do not have liters. What? We need to get to liters. So first, before we even start calculating molarity, we're going to have to convert into liters. So remember, we put our given over 1. And then we want to have our units on the bottom to cancel out. And what we're converting to on top. So we have 1,000 milliliters in 1 liter. So this is going to be 0.5. I'm just going to double check that because I make mistakes. Yep. So that's how many liters we have. And now we can solve for molarity. You have to have liters to solve for molarity. So no use in skipping that step. So we have this 3.083 moles over 0.5 liters. What does that equal? $61.6. Ooh, I did it wrong. Oh, everyone makes mistakes. 3.083. Oop. Just 0.5. 6.1. Oop. Said 6.1 or 6.2 if we round correctly. Come on, Gray. 6.2 molarity. So that's how you calculate molarity. Hopefully this was a chance to get you some practice. And I will see you tomorrow.